So what we are going to see now is hacatalog. Okay, so hacatalog is the facility, you can say, or tool or utility or whatever you can say. Basically, it will give you the way to since like we in Hive we have table, that is the schema, and the data also, right? So in Pig, if you just want to do some certain transformations on like Hive table, you can directly fetch the Hive schema information and the data related to that table into Pig, create a relation, pull the data into it, then do some transformation, and you can again export it back to Hive. Okay, so this is important in terms of you can also tell this to be the Hive and Pig integration through hacatalog. Okay, so since they both are working on the HDFS data directory, we can we need to have this kind of connection between Hive and Pig. One more thing is that this hacatalog question would be there in your certification exam. Okay, so out of 2 questions in Pig, 1 question will definitely come for hacatalog, where they will ask you to fetch the, give me 1 second. So out of so what we need to do in that question is basically we need to in that question they will ask you to they will give the information about the Hive table, where it is, in which database it is. Basically they will ask you to have the data in the Pig first, then do some transformation in Pig, and then export the filtered record into the some either in the same table or some other table matching that schema. Okay, now we will see that how we can do that. Okay, so what we will do is we will start Pig, Hive, and in Hive we already have one school table. Basically we will first bring it, we will try to modify it or filter some of the columns with some matching values, and then we will so basically in that question you have 2 tables. One table in that question in Hive, basically you will have 2 tables. One table is having data, another table would have just a schema but no data in it. Okay, so what you need to do is you need to bring the data from the first table, modify it, select some columns that will match the schema of the second table, and then once you get that, you just need to export it back. Okay, that is what is the ultimate aim of that question. Okay, so in that they will check both the hacatalog import and hacatalog export. Okay, to work with hacatalog, basically we need to start hacatalog in hacatalog mode. Basically, so how you can do is you need to say Pig and then use hacatalog. So it will import the libraries in which your hacatalog classes are there. Okay, though, and that will be actually placed into the Pig class path, so that Pig can access those classes to get the data from and put the data into Hive. Okay, the classes are org.apache.hive hacatalog Pig hacatloader. So this is which is used for loading the data. Okay, and loading the data from Hive to Pig, and hcat storer will store the data from Pig to Hive. So this is like vice versa. Okay, so I will use Pig, and then I will pass the switch X, not use H. Just remember this H and C is capital in hacatalog. Hacatalog. Okay, and then in Hive we have use underscore example. Now what we will do is basically in Hive, let's create a table without the data. Okay, so that we will have a table to which like we can export the data from Pig. So currently we have a school, right? So describe extended school. It will tell us whether it is a partition table or not, or what is the location and all. So currently partition keys are none. Okay, and this is the thing. Now if you describe it, describe school, you will get the schema of it, right? Now let's bring only these 3 columns. Okay, and that to 4 columns, and that too for, let's say, class 12, then have created separate table. Okay, now how do I create a table with only this 4 columns out of this school table? Okay, so that is now hive way to do that. Basically I will say create table, I will say pig school, something like this. Okay, so this is the table name, that would be the newly table created. Create table pig school as select. Okay, select what? Serial number, first name, last name, and class from the school. Okay, and then let's also put Hadoop underscore example in front of it so that it will be created in that. And also while selecting, just put Hadoop underscore example dot. And now the thing is, now this is very good interview question also for Hive. You just need to copy the schema. You don't need to, you need not to copy the records. Okay, now how do you do that? So I'm creating table. Okay, I know that I'm going to select only serial number, first name, last name, and class. These are the 4 columns we are going to select from the school table and create our new table called pig underscore school. But if you just end the statement here and run it, basically it will select the records also. So how do you select only the schema but no records should be there? Okay, this is a very good interview question in Hive. Though it is not a Hive specific interview question, it is mostly SQL related question. So you just need to put 1 equals to 2, and we know that there is no record where this would be true, right? 1 is equal to 2 in no records in the school table. This criteria will be satisfied. It means that no record will be selected. But what it will do is it will create the schema for you. Okay, with this 4 column and their data types and all. Okay, so let me just run it. Now what it says in the source table. Oh, we need to put where. Sorry, we are missing where clause. Okay, now what it will do is basically it will just create this schema, but no records will be copied. Okay, so this is the table that we are going to use while exporting the results from pig. Okay, so what we will do is we will load the data from this table into pig relation, try to modify it, try to select only that columns, and then export that back into this pig.school so that we will just have the records for that. Okay, now if you do describe this one, you will get only 4 columns, serial number, first name, last name, and if you do select star from, we should not get any, sorry, we should not get any records in this. Select star from, so there is no record, right? So it means that the schema is there but the records are not there. Now go into pig. So here what we will do is we will first create, first thing is you can load both the schema that way. So I will say school pig, so I am just trying to have the schema of a school pig. Okay, so this is the relation called school pig, and I'm going to use load table using this. Okay, load table using, now you need to remember this because you are not going to find it anywhere. You need to just engulf it in your brain, that org.apache.hive, then hcatalog.pig.hcatloader. Okay, so while doing the practice of it, you need to write it by hand, try to memorize it, try to remember it till the examination, basically, because this is just package org.apache hive hcatalog pig, and the class is hcatloader and hcatstorer. Okay, and then also you need to be very careful that H and C is capital and L is also capital. Here H and C is capital and S is also capital. Okay, so you need to memorize it. So I'm saying load table, and what is the name of table we will have is Hadoop underscore example, and I think we have created what, pig school or school pig? Pig school. Okay, so this is reverse way we are using it. Pig school. Okay, so relation would be school pig and the data that is going to be loaded is pig school, but there is no data in pig school, right? So it means that we will just get the schema from it. What it says, unexpected character. What is the character? Okay, so this character should not be there. It should be this quote. Okay, since I copied it from the document, in the document the quote is something different. Okay, so we should use this straight quote. Now it will connect to the meta store. It means that it has found the hive. Okay, it's getting connected to meta store, and now I think it is done. So if you describe on it, describe school pig, you will see that you have got the schema, and you automatically see that the type of, when we saw describe over here, so you see that this two data types, these two columns is having different data types. It is string data type in hive, though it is converted automatically by hacatalog in char array in pig. Okay, so there is no string data type in pig, so it is automatically converted into char array. While as exporting, all this char array will be converted into a string. Okay, so we need to be very careful while exporting or importing basically, and it should be matching data type. So okay, so we need to be very careful about the data types, right? String to char array. So always be cautious that don't try to export it in some integer or try to import it in an integer basically. Though hacatalog will automatically convert the data types for you, but if you're trying to do manually something like that, so just be cautious about the data types you are using to transfer the data from each other. Okay, now in a similar way, so we have school big creation. Now we will just create the school one. Okay, school Hadoop underscore example and school. Okay, using org apache hive hacatalog pig hacatalog. In this case, since school is also having a data, okay, it will also be loaded with its schema. Okay, so if I say describe school, I will have this schema, and if I do dump, right, dump school, I should get, I think I can also use limit. Limit is the keyword that will just select, I think, the first two rows out of this data. So we may have multiple rows. Okay, so we have got the results, though it has given a maybe limit is not working over there. But okay, so we have got the data as well as the schema. Now what we'll do is we can just say for each. Because the thing is, now we need to select for each. I can say there should be the relation name, let's say columns. Okay, for each is cool. Generate what we need to generate: serial number, first name, last name, and class, right? So what it says now, for each school, generate serial number, first name, last name, class. Syntax error, symbol near do we not have that? Here is a problem. Big script failed to parse for each school. Generate serial number, first name, last name, class. No, it is correct because I had some typo over here. So columns are those, right? Now on the columns, basically what we need to do is, I will say filtered relation on columns. We will say filter columns. We can use by, let's say we want to bring only class 12th students in it, right? So we are now filtering it out. So filtered is created. We can dump and try to see that only these 4 columns data needs to be there and only for class 12 is there. Okay, so we have if you describe filtered, basically you have identical schema, first name, serial number, first name, last name, and character array. Okay, sorry, class that is exactly matching to the pig underscore school, right? So we can now use this filtered in order to store it back to pig underscore. So I will say we need to store it back, right? So we need to use the separate class that is called hcat storer. Okay, so I say store relation, what is the relation name you have into table using this one. Okay, so we will try to make it over there. The first thing that we need to correct is this quotes. That should be like this. The name of table that in which we are going to put this underscore example dot, what is the name of the table is pig school, right? Pig school. And what is the relation we are going to store is filtered. Now we need to be very sure that filter is store filter. So this relations schema and the schema of this table should be identical in terms of at least name of columns and then their data types. Though their data types cannot be matched, so their data types will be converted automatically by this hcatalog storer, hcat storer. Okay, and let's fire it. Now it is telling us success. It means that it has loaded the data. Now if we need to go here and try to select on it, and we have got the result. So there are 3 students, 12, 12, 12. Sorry for this. Now if you see, we have the records right in Hadoop underscore example pig.school, right? So basically this pig.school, it was having only a schema at the earlier point, but now we have exported the records by using some pig transformation and used the schema. So this is the right way. So before you think of exporting the records or data from pig relation to some some table existing in hive, we need to first get its schema so that we can match the extraction of records using pig as per that schema, and then export directly, so that schema to schema everything should be mapping, and the data will be copied from pig to pig relation to the hive table. Okay, so this is the exact same approach you need to use in the examination, okay, to crack it. Okay, and I'm sure that it's not huge. I mean, you will just so if you know this trick or you know this approach, basically, okay, you just need to practice a few of more scenarios, but this is the scenario that will be asked in your examination, certification examination. Again, you can finish it if you know the approach very well. You can finish that question in 10 minutes, not more than that. Okay, now this is how the hcatalog will help you to load the data from hive and export it back to the hive. Okay, and what we have done is we have loaded the data using hive. We did some kind of operations on it and then match it to the final destination schema and then exported it back to hive. So now there are bad data. So this particular question, this particular scenario is being asked for in interview questions for most of the components. Like scoop, they will ask how do you handle the bad data in a scoop. Okay, how do you handle the bad data in hive, how do you handle the bad data in pig, okay, or any other framework. Okay, bad data is the most problematic you can say thing that is getting faced in most of the scenarios. So basically, when processing gigabytes of gigabytes or terabytes of data, the odds are overwhelming that at least one row is corrupt or will cause an unexpected result. An example is division by 0, even though no records were supposed to have a 0 in the denominator. Causing an entire job to fail over one bad record is not good. To avoid this failure, pig inserts nulls, issues, warnings, and continuous processing. So basically, it is eating anything. Okay, when if you give bad records to it, you will get a null for that. Okay, it means that while calculation, it does not throw you an error, and since it is getting some internal Java errors, and if it is not calculating the final values, okay, as per whatever formula, as per whatever expectations you have been given to the pig, basically it will just replace the final result as null. So later on, wherever you will just say a query on it, or you just need to find that what are all the final results you are having null. Okay, and for that you just need to inspect the input records for that. Okay, so you can also, in case of null, try to find out that what is the input record and why it has given you null. Okay, for other records the final output is proper or it is okay. Okay, so it internally handles that bad data, but then it won't tell you why it has failed. It is null. So basically you may need to rerun the process for those bad records, try to identify what is the root cause of it, maybe some problematic data. Suppose if it is comma separated data and the data itself is having comma. So the major problem in Hadoop is, like, most of the times you will work with text data. Okay, though while storing it on Hadoop side, basically you may use multiple different formats like ORC, Parquet format, sequential format, binary format, and then on the top of it also you will compress it by using XNAP compression or LZO, bzip. There are multiple compressions also, right? So there is two different things in Hive. One is called data format. Okay, data format is different and encryption techniques are different. Okay, this is two very different things, so don't get confused in this. So when I say in Hive, in Hortonworks, the platform that we are using currently for our practical purposes, basically we mostly use the table is to be ORC format. It is called optimized record columnar format. Okay, that is the format of data, not the compression. Okay, the compression is different. The compression will just try to save you the space of storing the same data, just like zipping the file, right? So whenever we have a lot of text file, what we do is we will zip it or 7-zip it or v-zip it. There are multiple that is what is said to be compression. Okay, you will try to reduce the size. But then some compressions may not be splittable, some compressions are splittable. Okay, so depending on different thing. So this is a very good scenario specific question that they will ask you, that which compression and which format you should go. Okay, in Hortonworks, if you are working on Hortonworks, the best answer is to use ORC format using snappy compression. That is, there is no alternative to that. Okay, they will use they can say, why don't Parquet, why don't sequence. You just need to tell them ORC, that is optimized recall columnar, is that format that also holds some kind of statistics within it. Okay, so for every 10,000 rows it will collect the statistics for that particular block. Okay, that will try to prevent the unwanted scans of the data, just to find, let's say, select star count, or what is the minimum, what is the maximum value of a column, what is the average value of a column. This kind of statistic it already saves for that particular block on the header of that data, and it will also tell you that what is the range of for a particular column is getting stored in that block. Okay, so while doing the queries on ORC format table, basically it automatically saves a lot of time for the query in order to scan the thing. So it will scan the range, it will automatically get you the total count of a column, total count of the records, total minimum and maximum of the columns. It already just give you out of the box without running any MapReduce or heavy time consuming MapReduce process on it. Okay, that's why ORC is best. In Cloudera, basically they are more prone to use Parquet format. Okay, so Parquet is again designed, not Parquet actually, it was Avro, but that was designed by duck cutting. So there are multiple formats. Okay, they are this data formats, right? Just like XML is a data format, JSON is a data format. It is not a compression. We cannot set the JSON and XML to be a compression, right? XML and JSON, they are human readable formats. Okay, while ORC, Parquet, Avro, binary, they are not non-human readable format. It means we cannot read that. Okay, it is like some appearing to be a junk to us. But XML and JSON, we can just read. Okay, this is a key value pair, right? In XML also it is a key value kind of pairs. JSON also is a key value pair data. Okay, that is unit. So most of the engines like Elasticsearch, MongoDB, Cassandra, okay, there are some other document data store, those work on JSON heavily. Okay, JSON is said to be a very good format of data that is equally human readable, very compact in things, and then it is easily being processed by Hive, Spark, multiple other platforms. Okay, so while answering the question of bad data related error in Pig, how to resolve this is how automatically it will be resolved. In Hive, basically what you can do, in Scoop also what you can do is we can try to see bad data. Okay, so we are having a book. So basically you'll find different techniques of so basically in this is like scoop we can read first. And so basically in scoop what we do is scoop import the data. There is the ability to skip the bad records at the time of import whenever any occur. So what we do is generally we are importing it through RDBMS. RDBMS is like a very strict check on it. So also the scoop does not have any ability to skip the records. Whenever they occur, you will need to check the log of map reduce job. That will what the exact error, whatever it is, data is. It will what you can do is basically there is a data conversion while bringing the data from RDBMS to scoop. So there is a facility of data conversion. Suppose if you see that the data, let's say date data, right? So date data may be some problematic data. Some of the times when you import it from DB2 or Oracle, it will give you the problem date data type. Okay, so you can convert that on the fly while bringing it. So instead of treating it as to be a date data type, you can just convert that into a be string and then just store it in your final table. Later on, then you can do some kind of operations to treat it as a date data type. Okay. So most of the times for the general fields, we do not see much error in the scoop since the data that we are actually bringing is very strictly checked data from the RDBMS. Okay, only the problematic field is date field. Okay, that you can just change. So there is the in the scope book you'll find one option where you can just change that to something else. In Hive, how to handle the bad data in Hive? So set map skip mode enabled. So use this property to skip the bad records. You can also set the value how many bad records you can skip. After that, you need to dump. Okay, if a large number of the incoming data is bad record, then you cannot keep all skipped. Okay, but still we need to do something with that bad data or at least report it. Okay, so we can just put it into the report something. Okay, so this is a property map.skip.mode enabled. Okay, so it will skip if any particular processing is failed due to the bad data. Okay, so that record will be skipped. Okay, but then if it is skipped, you need to figure it out or you need to just log it somewhere. Okay, this is skipped or this whatever serial number or any unique key related to that or any information related to that record, you need to save it somewhere. Okay, so this is a property mostly you can use. There are other ways also, like if you can anticipate that what could come, just like a comma separated values, right? So the CSV data, what we generally use is a comma separated way. Basically, what happens basically if the data itself is having commas in it, right? Just like address field. In address field, you are having address field in the comma separated values, but then address itself is having certain commas within it. Okay, so basically it will split that record over there and it will basically corrupt your data. Okay, so that case, okay, where you are getting some extra delimiter within the data itself or delimiter itself is a part of the data, then it is very difficult for that kind of data to be processed, because then you will definitely mismatch the schema. Okay, so you need to check or you need to then again ask the business to correct the data and then send. Otherwise, definitely you will get a lot of errors with that. Okay, if you feel that the comma is not the good separator, since there is a data itself is prone to have the commas within, so then you can ask the business to connect, either make it to pipe delimited or some extra character delimited. Okay, so that just like pipe could not be, or most of the times if you see pipe is not the part of the data itself. While most of the data does not have the pipe to be the part of the data. Okay, so you can ask the business to convert that in, because it is very difficult. I mean, we cannot manage everything at our side. Okay,